We've done some enhancements to the R32V2020 RISC CPU instruction set. Let's take a look. We've always had immediates and the ability to load a register with an immediate value in a single instruction, or at least half of the register, and if it's sign extended, the whole register. But what we lacked was a compare immediate or other ALU operations with immediate, and we've added those in. Another thing we added was the ability to auto-increment the peripheral and data buses after a read or a write. This eliminates a couple of instructions to add to the pointer after every transfer and greatly speeds up transfers between the CPU and the memory. Let's take a look at the programmer's reference card to see those additions. So for the arithmetic functions, we've added an immediate here, and it takes a 16-bit value, adds it to a source register, and stores it in a destination. That should be RD. I'll have to fix that. Subtraction, same thing. We've added a immediate 16 value, added to the source and or subtracted from the source and stored in the destination. We've also done the same thing for the multiply instruction. The logical operations also did the same thing, OR and XOR immediate. For the data bus, data memory bus, and the peripheral space, we've added post increment instructions. So if you do a load data byte with a P on it into a destination register, it'll load what the data pointer R6 points at and put it into the destination register, and then auto increment that R6 after the instruction completes. Same thing with the loads and stores to the peripheral bus. This again greatly speeds moving things in and out of memory because you don't have to play with the pointer. The difference is easily illustrated here. We were doing quite a few of this sequence of load immediate with a value, compare it to another value, and then branch, and that basically cut that down to a compare immediate, which is a very common function to do that, not having to do the extra load immediate into the register and just being able to directly compare saves quite a bit of performance, increases quite a bit of performance. We created a little test to show that it works. Fairly simple. Load 1, 2, 3, 4 into R8, add 1 to it, and then subtract 4, and then compare immediate to 1, 2, 3, 1, and if it was equal, go to good value, and if it was not, then display bad on the 7-segment display, and it worked just like it should. So we're tracking issues in the GitHub site itself with the Issues tab, and have quite a few closed there, have a few still open, and it's a real good way to keep track of what functions are being added. And in this case, I'm collaborating with my son, and he's doing work on the assembler, so we're able to cooperate together, and I can open an issue, he gets notified there's an issue, he can deal with the issue when it's convenient for him, and then he can close the issue, and it works quite well. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.